Hello friends, and today we are here to discuss the chapter and welcome to another video of carbon and its compounds. So today we'll be studying the chemical properties of carbon's compounds. First, carbon in its allotropic form burns in the air to give rise to carbon dioxide and heat and light. This is known as combustion reaction. There are three equations given in the book for the combustion reactions which have to be balanced themselves. The last one is ethanol burning in the air to give us oxidized ethanol and heat and light. So this is what is produced after we burn carbon's compounds. One more interesting thing here to be noted is that what is the difference between unsaturated burning and saturated burning? When saturated hydrocarbons are burned in the air, then they give a clean blue flame. While if unsaturated hydrocarbons are burned, then they give a sooty flame. They give a sooty and a yellow flame with a lot of black deposit. So this is the difference between the unsaturated and the saturated burning. But sometimes, because of incomplete combustion and in the lack of oxygen, even saturated compounds start giving a sooty flame. So this is a wastage of our LPG and our other fuels that we'll be using. So we have to check if the bottom of our vessels are getting blackened. This means that the inlets from which the air enter the gas, the gas stove are blocked. So we need to clear them so that air can flow and complete combustion of saturated hydrocarbons will occur, and so we'll have a clean blue flame with no sooty deposits. Another thing, carbons sometimes have some nitrogen and oxygen, some nitrogen and sulfur in them, and so after burning they produce sulfur oxide or nitrogen oxide. These are the major sources of pollution for the environment. Now let's close the chapter of combustion and go on to another reaction that is known as oxidation reaction. As the name suggests, oxidation, oxygen atom is going to be added to the compound. Carbon compounds easily get oxidized when they are burned or when they are combusted. And also there are some reactions. For example, the reaction of ethanol with the oxidizing agents such as potassium dichromate and the alkalis, like the other oxidizing agents we can produce from the ethanol. रीस्टार्ट कर रही हूँ मम्मी यहाँ से Carbon compounds can be easily oxidized when hello friends, and now we are going to discuss about oxidation reaction. Let's close the chapter of combustion and come to oxidation reaction. Here what happens in the scene is that carbon compounds are easily oxidized when they are combusted or burned. But there is a very interesting reaction when ethanol is burned with the presence of potassium dichromate. Then we can produce carboxylic acid from these. Then what is potassium dichromate in this reaction? Potassium dichromate in this reaction, acidified potassium dichromate in this reaction is actually an oxidizing agent. An oxidizing agent adds oxygen to the compound, as the name suggests. Now we are going to go on to the addition reaction. Addition reaction is something is going to be added in the addition reaction with the help of catalysts. So first let me explain what is catalyst. Catalysts are the substances which increase the rate of reaction or make the reaction happen without something happening to itself. For example, if I am a catalyst, if I am nickel, let's say for this reaction we are going to take nickel. If I am nickel, then I am going to make a reaction happen without myself being affected in that reaction. So that reaction is the hydrogenation reaction or adding of hydrogens. Sometimes unsaturated hydrocarbons, in unsaturated hydrocarbons, hydrogens can be added with the help of catalyst, and so they will become saturated hydrocarbons. This reaction is being extensively used in the hydrogenation of unsaturated oils. Okay, so for example, this reaction will go like C double bond C, and then we'll have 4H. So for example, let's take the example of ethene, C2H4. Then we'll have two H's added in this reaction, and it will become C2H6. That gives us an ethane. So this happens. Now you might have seen in the advertisement that some animal fats are healthy, so-called healthy, and some animal fat some oils are not healthy. Fats are not healthy. So it's it's like it's said that unsaturated hydrocarbons are unsaturated fatty acids are healthy, while saturated fatty acids that normally animal fat contains are unhealthy. So that is why we should use unsaturated oils for our quick cooking. Then comes the substitution reaction. As the name suggests, in substitution reaction, a atom or a molecule will be replaced by another. Though saturated hydrocarbons are quite inert in the presence of other reagents, but when chlorine is added in the presence of sunlight, a very fast reaction occurs in which chlorine starts taking place of hydrogen one by one. So in the book it is given like C4, CH4, Cl2, and the reaction occurs, and Cl has taken the place of H, and HCl is formed. So Cl is taking the place of hydrogen here. That is why one atom is replacing the other. That's why it is known as substitution reaction. Then we go on to some important properties of some important carbon compounds. That is allotropes of carbon, I must say. That is ethanoic acid, ethanoic acid, and ethanol. So first we'll be discussing ethanol, then we'll be discussing ethanoic acid. Ethanol is liquid at room temperature, as you all know, and ethanol has a melting point of 156 Kelvin. Then it has a boiling point of 351 Kelvin. Now one interesting thing is that the boiling point of ethanoic acid is exactly 391. That is exactly 40 above the ethanol. So you can remember it like that. Then ethanol is an active ingredient of alcoholic beverages, and it is also a good solvent. So it is used as a solvent for tincture of iron and syrups and medicines. Ethanol is also known as alcohol, and alcohol is not a very good drinking alcohol is not a very good practice, but still it's widespread in our society. And regular consumption of alcohol on regular basis can be very harmful for health, and if you take even one drop of pure ethanol, then it can prove to be lethal. So really be careful in these things. Then we are going to talk about some of the reactions of properties of ethanol, that is reactions of ethanol. First we are going to talk about the reaction of ethanol with Na, sodium. So in this, hydrogen will be released and sodium ethanoxide will be formed. Then we are going to have the reaction in which ethanol is converted into ethene. So here what's going to happen is when you burn alcohol with ethanol with the concentrated sulfuric acid at concentrated sulfuric acid, then you get ethene and H2O. CH2 and H2O. So this is like converting ethanol, that is another branch, to ethene, that is a unsaturated hydrocarbon. Now after that comes the properties of ethanoic acid. Ethanoic acid is commonly known as acetic acid. Its 5 to 7% of solution in water is known as vinegar. Now vinegar is used for preserving pickles and whatnot. We actually use it for everything. Even we put it for cooking in the vegetables and all of that. Then one more property that ethanoic acid shows is that it has a very low melting point, 290 Kelvin scales. So Kelvin. So when at low temperature, slightly low temperature, it freezes. Then it's known as glacial acetic acid. Now the group of acetic acid has a special acidity, but it's not a very strong acid like the mineral acid. It does not completely ionizes in water, and so it's a weak acid. Now we are going to see some of the reactions of ethanoic acid. First one is esterification reaction. When ethanol and ethanoic acids are reacted with each other, then we get these esters or ester formation reaction, as I told you from in the beginning. Esters are sweet smelling liquids which are used in the formation of perfumes and soaps, and when these are treated with sodium hydroxide, that is an alkali, we get back ethanol and the sodium salt of acetic acid, that is soap. So this is known as saponification reaction. After that we have the reaction of acetic acid with Na, that is sodium. Here also we get sodium salt of acetic acid as well as H2O. Then after that we have the reactions with hydrogen carbons and carbons. Here carbon dioxide is released as well as water is formed in both of the cases. So this is very common and you can balance the equations very easily. After that we have soaps and detergents. That is a very soothing kind of a topic that's very easy but very interesting in itself. What are soaps? First I'm going to clear you what are soaps. Soaps are long chains of acetic acid. Sodium salt of long chains of acetic acid are known as soaps. So they have two ends, hydrophilic and hydrophobic. Hydrophilic end is the end where Na is present there or sodium is present there. So it will go inside the water, hydrophilic. And the second end is hydrophobic. It's fair full of water, but it's dissolvable in oil. It is the hydrogen carbon end. That is why it will dissolve in oil. So how does cleaning happen? If you have to describe the cleaning effect of the soap, how will you do so? First we will describe that what are soaps. Then we will describe what is dirt. Dirt is oily in nature, and so it does not dissolve in water. So when we start washing our clothes, what happens is that the hydrophobic end is going to be dissolved in the water, while the hydrophobic end is going to be dissolved in the dirt, while the hydrophilic end is going to be dissolved in the water. So one end will be towards the dirt and one end will be running away from the dirt. This will form what is called micelles. This will form micelles, and these micelles will help to dissolve the dirt in water, and hence we can wash our clothes clean. Now also sometimes when we are bathing, we have one problem, that micelles are not formed and something like very sticky and not that like foam like forms. It's scum. And why does it forms? Because when these soaps react with magnesium or calcium, then this happens, and these two are responsible for magnesium and calcium salts are responsible for the hardness of water. So what should we do in result? Because we cannot even wash our clothes, then a lot of soap will be wasted. Then we use detergents. Detergents are ammonate or sulfonate salts of long chain hydrocarbons, again long chain acetic acid. So here it is not affected by the magnesium and the calcium content in the hard water, and it can easily clean your clothes. So this is the end of this chapter. These detergents are used in the making of the shampoo and the liquids for cleaning your clothes. So this is the end of this chapter, and if you want to know more about this chapter, you've got to see my other videos as well. But there is nothing left to know more about this chapter, so please let's go on for chemistry. And if you want to know more about the chapter periodic classification of elements, then you've got to see my other video as well. Thank you.